Welcome to EPG Pathasala. I am KP Rao, Professor, Department of History, University of Hyderabad. Under the subject Indian Culture, in the paper Principles and Methods of Archaeology, today we are going to learn the methods that are used in remote sensing in archaeology. The name of the module is Remote Sensing in Archaeology. So the objectives of this study is, the main aim is to study the basic principles of remote sensing, the satellite basics, the concepts relating to spectrum, that is the light spectrum, and image acquisition using remote sensing, and applications of remote sensing in archaeology. So this let us first learn what is remote sensing, the meaning of remote sensing. So remote sensing is basically the capacity to see or sense a distant object and perceive its shape and size and character is known as remote sensing. So remote sensing capability is in a way it is also a natural capability that is available to most of the living species. For example, our vision, our hearing capacity, our smell, all these are actually remote sensing capabilities. That is, we don't need to go near the object or touch the object, but even then we can perceive the characteristics of the material. So that is, in simple terms, that is remote sensing capability. So nowadays we are using various means like the satellites or aircrafts or hot air balloons, etc. Various kinds of means are used to collect the remote sensing information. So usually the satellite remote sensing is the technology of acquiring information about the Earth's surface without actually being in contact with it. So satellites are the most extensively used medium to conduct remote sensing because they have the maximum capability to undertake this remote sensing extensively and relatively at a cheaper cost. Though, of course, we can, as I was telling, we can use aircraft, helicopters, balloons, kites, and even the birds also have been used in remote sensing work. But the satellites are the best medium to collect the remote sensing information. So let us first see briefly the history of remote sensing. So it is known that the French photographer Gaspard Felix was the first person to have used hot air balloon to take photographs in 1858. So this is the first activity that involved some kind of remote sensing. And afterwards, in 1882, E.D. Archibald, an English meteorologist, also used kites to take aerial photographs. So these are the first attempts to take aerial photographs. After that, especially during the two world wars, aircrafts were extensively used to spy on the enemy establishments. So to study the enemy establishments during the First World War and the Second World War, aircraft have been extensively used to take photographs, especially of the enemy land. So at that time they have used the remote sensing techniques for military purpose. And then the first space-based photo was taken in 1947 by using a Viking sounding rocket from about 227 kilometers above the surface of the Earth. Some photographs were taken, and these are the first space-based photographs taken anywhere in the world. So let us now first learn some of the scientific principles that are behind this remote sensing. So as I was telling, remote sensing is based on capturing the radiation, that is the energy emitted by a feature. So the collection of the information, that means the collection of the information is basically dependent on the kind of energy or the radiation that is emitted or coming out of a feature. So the energy that is coming out of a feature is used for collecting data about that feature. So that is the basic idea in using remote sensing for collection of the data. So this emitted radiation is usually gathered by sensors. So these sensors have the capability to capture various kinds of radiations, visible as well as the radiations which are not visible to the human eye also can be gathered by these sensors. Once the radiation is gathered by a sensor, the information or the data is required to be further processed by using various kinds of computer softwares to extract information like the color of the radiation, temperature, or the elevation of the feature, the size of the feature. So all this information can be gathered by further processing the data that is captured by the sensors. So remote sensing involves collection of data from the material, that the radiation that comes out of the objects. So let us now learn the basic principles that are involved in the satellites and satellite operations. So satellites are basically man-made machinery that encircle the Earth at certain distance. So satellites follow a particular path, usually known as the orbit. Usually there are two types of orbits. One is equatorial orbit and the second is polar orbit. So an equatorial orbit is taken by satellites that go around the Earth above the equator. That means the satellites that take this equatorial orbit, they encircle the Earth just above the equator. And the polar orbit is taken by the satellites that go around the Earth, passing over the North and South Pole. So the polar orbit is usually taken by the satellites that go around from North Pole to South Pole and again climbing up to North Pole. In that manner, the polar orbit is taken by the satellites taking polar orbit. So this equatorial orbit is usually used by the satellites known as the geostationary satellites. So these geostationary satellites are positioned at a fixed distance and place above a particular region. So relatively to the motion of the Earth or the rotation of the Earth, the geostationary satellites maintain the same position above the Earth. Usually these geostationary satellites are used for communication purposes, like transmitting the TV signals, radio waves, or telecommunication signals. So they are mostly used in telecommunication purposes, or sometimes they are also used by the defense establishments or for some strategic purposes to constantly observe a particular region for movement of to observe the movement of the troops, or to have observations about similar things. For remote sensing, the polar orbit is the most useful orbit. So that is why mostly the remote sensing satellites use the polar orbit. The advantage of the polar orbit is that at some given point, a polar satellite can gather information from all parts of the Earth, because the polar orbit takes orbit rotates from North Pole to South Pole and South Pole to North Pole. What happens is, by the time the satellite covers one region and again comes to the same position, the Earth would be rotating because of Earth's rotation from west to east. What happens is, by that time the satellite again comes to the same position, the Earth would be rotating, and then a new region would be coming in the view of the satellite. So because of that, the polar orbit satellites have the capacity to observe all parts of the globe at some point of time. So that is the advantage of polar orbit. So this then let us learn the basics involved in collection of remote sensing data. So that is, as I was telling, remote sensing data is based on the collection of the data using the light spectrum. So light is basically an electromagnetic radiation which consists of different wavelengths known as the spectrum. So the visible light consists of the radiation having wavelength of about 390 to 700 nanometers only. So the 390 to 700 nanometers is the visible radiation, electromagnetic radiation. So beyond this 390 to 700 nanometers, our human eye cannot see or sense the electromagnetic radiation, whereas the satellite sensors and other instruments can detect the radiations which are beyond this spectrum, and they are used in the remote sensing. So apart from visible radiation, other radiations like the infrared radiation and the radio waves are also used in remote sensing. So usually the radiation that is incident in the sense that is falling on an object, may be absorbed or reflected or transmitted. So when electromagnetic radiation falls on some feature or an object, it may be most portion of this radiation may be absorbed, or otherwise sometimes some of the radiation may be reflected, or most of the radiation may be reflected, or sometimes this radiation or this incident radiation could be transmitted also. Transmitted means it may pass through, like thin leaves. So thin leaves transmit some of the radiation falling on them to the other side. So this when radiation falls on any object or feature, any of these three things may happen in relation to the radiation. That is, the radiation may be absorbed, or the radiation may be reflected, or the radiation may be transmitted. So now let us see how this radiation, the electromagnetic radiation, reflected radiation, is collected. So that is, let us learn how the collection of the remote sensing data happens. So for remote sensing, the radiation that comes out of the feature is more important. That is, the radiation coming out of the object is more important than the radiation even falling on the object itself. So for us, the reflected radiation or the transmitted radiation, etc., is more important than the incident radiation itself. So some of the radiation may be promptly reflected back. That means whatever radiation is falling, that may be immediately reflected back, or some of the radiation may be absorbed, or it is also likely that some of the radiation that is absorbed is released later. So when the radiation falls on a feature, any of these results could be there. That is, it may be promptly reflected back, or it may be partially absorbed, or it may be sometimes absorbed when the radiation falls on it, but reflected back at a later period. So any of these effects could be there. The reflected radiation may be entirely of different character than the incident radiation. Sometimes what happens, a particular kind of or particular wavelength of radiation may be falling on the feature, but the reflected radiation may have a different kind of character. That is, sometimes the wavelength of the radiation that is coming out of the feature may also change. So any of these effects could be there, and in the collection of the data, all this information is very useful in remote sensing. Now let us learn how the image, the remote sensing images are acquired. So that is image acquisition. So the remote sensing data is gathered by sensors. So the sensors may be either panchromatic or multispectral. So there are various kinds of sensors. So panchromatic, that is the sensors that have capacity to collect data about all the visible radiation. So all the colors can, the information about all the colors can be collected by the panchromatic sensors, or otherwise there are also multispectral sensors. So multispectral sensors are more sensitive specters. So sensors. So the multispectral sensors are used for gathering radiation within a specific spectrum. So that means we can selectively collect information about specific spectrum by using multispectral sensors. So and in remote sensing, usually we have two kinds of remote sensing. One is known as the passive remote sensing, which uses sunlight for gathering the information. So sun would be the source of radiation for gathering the information in passive remote sensing. And the other mode of remote sensing is known as active remote sensing. And in active remote sensing, we send the radiation usually from the satellites or the body that is used for collecting the information, like the aircraft or balloon. So in active remote sensing, the radiation is sent by the machinery that is used for collection of the radiation. So usually the lasers and the radar waves are used in active remote sensing. So this I was telling you that there are different kinds of sensors. So multispectral sensors can detect about 3 to 10 bands of information. So the sensors having capacity to collect information about 3 to 10 bands are known as the multispectral sensors, whereas there are more sensitive sensors which are known as the hyperspectral sensors, which can detect about 200 bands. That means the selection of the spectrum in each of this sensor is very narrow. So that means we can collect very specialized information using this hyper spectral sensors. And naturally, since so many bands of information is collected, hyperspectral images have maximum potential to detecting minor variations in the features of the object. So hyperspectral images naturally contain large volume of data also, because it contains information about different kinds of spectrum up to some 200 bands. So then let us see what are the advantages of using remote sensing in studying the features or in studying the archaeological sites, etc. One of the main advantage of using remote sensing data is that it is very cost effective. That means at a very low cost we can survey or gather information about a very large area. So that means it is less expensive than undertaking the ground-based investigations for collection of the data. So this is one of the main advantages in collecting the data using the remote sensing techniques. And also it is very time effective. That is, it saves time. So for collection of data, since the satellites are used, we can get data about a large area in a very short time. For example, if we acquire image from a satellite based data, then the image can be processed using the computer techniques, and within few minutes or few hours you can have the data about a large region. For example, like elevation data. If you want to collect elevation data of something like 100 square kilometers, using the satellite techniques, it is possible to have the data within a few minutes. Whereas if you do the same kind of survey for collection of the elevation data, then it might take several months together to survey this 100 square kilometers of area. So that is the satellite data or the remote sensing techniques are very time effective techniques. They save lot of time. And then the remote sensing techniques also are very useful in detecting invisible features. So the features which are not visible to the naked eye also can be detected using the satellite techniques. For example, detection of the paleo channels. So in a particular region, if a dormant channel or a paleo channel, that is a channel which was flowing long back is there, it won't be visible to the naked eye. We cannot detect by the naked eye. But by using the infrared techniques, we can detect the paleo channel. So the feature which is not visible to the naked eye also can be detected using the remote sensing techniques. So, and also the remote sensing techniques also can survey inaccessible areas, especially like the forests or the zones, dangerous zones like where various kinds of dangers are there, like volcanic activity, etc. So such areas can be surveyed using remote sensing techniques. And also the ground factors like a war or enmity between two countries, and such factors also cannot affect the data collection. So even in such dangerous zones, also the data can be collected using the remote sensing techniques. And then it is also possible to have real-time monitoring by using various kinds of satellites. It is possible to get the dynamic data from the zones that we want to observe. So real-time monitoring is also possible in remote sensing techniques. So this let us see how the remote sensing techniques can be applied in archaeology. So first of all, in explorations, so that is explorations which are that techniques that are used in finding the new sites, we can use this remote sensing techniques. So usually wherever we have some habitation or some archaeological feature or site, it is observed that there would be some change in the color of the soil. So in using the remote sensing techniques, if we process the image and we can use the techniques like identifying the spectral values of the pixels. What we can do is we can identify the spectral values in the selected region of the known sites. If we know a habitational site, and if you know the spectral values of that land, the same criteria can be applied to search for the new sites using the softwares. So the softwares will point out where in which other regions the same kind of spectral values are present. Like that, we can detect unknown sites by using remote sensing techniques. So, and also the remote sensing techniques can be used for detection of the paleo channels. Paleo channels are the rivers that were flowing in the past, and due to various reasons like a change in the course of the river, or due to due to factors like obstruction in the flow of flow in the channel, what happens is these channels in course of time they get buried by the sediments and other deposits, and they are not visible to the naked eye. So these kind of channels are known as the paleo channels. As you know, the human cultures and civilizations persisted along the river courses and in the valleys. That means getting data about the channels and the river courses of the past periods is very important in understanding the cultures and civilizations. So what happens is when a channel gets buried in course of time, yes, it ceases to have the river flow. The channel is usually buried by sand and usually softer kind of wind-blown sediment, etc. So this kind of sediment that gets accumulated in the channel has some uniform characteristic, and it is usually somewhat loose compared to the surrounding regions, and also it contains a lot of moisture. That means there are differences in the deposit or the soil that has accumulated in the channel, and the deposit or the that is available in the bank regions, banks of the river. There is a lot of difference. So because of this difference, what happens is, usually in the region where the paleo channel was there, since it has somewhat loose and sandy kind of material, it retains more water. So the reflective and absorption characteristics of the materials differ from material to material. That is, the rocks have some kind of reflective characteristics, and also the absorption and reflective characteristics. Rocks get heated up quickly and also lose the heat very quickly, whereas the water acquires the heat slowly and also loses the heat very slowly. So this kind of differences are there in the paleo channels also. Paleo channels, since they contain more moisture, they tend to absorb the heat slowly, but at the same time they retain the heat for longer hours. That means even during the night also, these paleo channels tend to release radiation in the form of infrared radiation. So if we conduct an infrared survey of the regions where the paleo channels are there, what happens is, since the paleo channel has more moisture, it would be releasing more infrared radiation late in the night compared to the surrounding bank regions. So this difference in the radiation that is coming from the paleo channel and the banks can be used in detecting the paleo channels. So like that, in archaeology, we can use this infrared technique in detecting the paleo channels. To give you one good example about this paleo channel, the scientists have studied the Ghaggar river course. So the Ghaggar river course, which has many paleo channels, has revealed that the Rajasthan region, which is now most of the region which is desertified, was in fact in the earlier period was having active river. So the remote sensing techniques have revealed the paleo channels in Ghaggar region, and that helped us in understanding the Indus Valley civilization, its decline in later periods. So like that, we can use this remote sensing techniques in study of the archaeological sites. Then the other important application in archaeology is the radar detection. So radar is an acronym of radio detection and ranging. So radio waves or radar waves can penetrate soil, sand and foliage. So radar waves can reveal buried features. Since the radar waves can penetrate soil or sand or even the forest cover, then these radar waves can be used to detect the buried features or the features that are covered by the thick forest foliage. So this radar can reveal features concealed by the forest cover. Radar technology can be used to prepare elevation model of a region. So since the radar waves help us in apart from revealing the buried features, since we can also know the distance at which the features are located, the elevation data can be used in preparing elevation model. And in fact, for preparing the elevation model, we can use the other kind of survey that is usually known as the LIDAR survey. So LIDAR is light detection and ranging, which is a survey conducted using laser pulses. So that means it is active remote sensing technique, where the satellite sends the laser pulses to the region to be studied. So usually the laser pulses that are sent by the satellite are reflected back, and the sensors calculate the time taken for the laser to travel from the satellite to the object, and then the reflected radiation, time taken for the reflected radiation to reach back the sensor. So that helps us in assessing the distance at which the object is located relative to the satellite. So using the laser survey, we can get the elevation data of a region. So usually this laser survey is most useful in topographic study of 3D modeling of a site. LIDAR technology is used for collection of basically this elevation data. So LIDAR can be used to extract contours of a selected region. Once we have the contour data or the elevation data, then that data can be used for preparing the 3D modeling of a region. So we have so far learned the various concepts that are related to the remote sensing. So in this presentation, you have learned what is remote sensing, the mode of collecting data, the concepts relating to the satellites and their orbits, and the concepts relating to visible and beyond visible range spectrum, the concepts relating to data acquisition, advantages of using remote sensing applications in archaeology, and its applications in explorations and study of the paleo channels, and the use of radar and LIDAR surveys, that is the laser survey, and also the usefulness of the remote sensing data in preparing elevation and contour extraction. So this is about the remote sensing techniques used and its usefulness in archaeology. Thank you very much for watching this presentation.